Hi friends, this is Sri Ramulu. So before watching this video, please subscribe it. Don't forget. So today's topic is Bravais Lattice. Bravais is the name of the scientist. Okay, he showed that there are only 14 ways of arranging points in space to that environment look the same from each point. The lattice are called Bravais lattice. Okay, here Bravais showed, okay, how many ways of arrangement points. There are 14 waves. Okay, so 14 ways are there. So that means lattice points can be arranged in 14 ways. Okay, 14 ways in space to that environment look the same. Okay, suppose see here from this side, if you observe how does this appear, from this side also it appears same, and from bottom it appears same. So like this, it's environment looks the same from all the direction. So that means it appears to us the same from all the direction. That is the meaning of this. And such lattice are called, what you call, such lattice are called Bravais lattice. Okay, how many lattice are there? Bravais, there are 14 lattice are there. So in the next video I will upload, there are the 7 different types of lattice are there. So again these sevens are these sevens are changed into 14 by applying the Bravais lattice. So that is why he is saying a 14 arrangement. Okay, so what are the main basic things to change this 7 into 14? So here three main lattice are there. So those lattice are given here. Now see those 3 lattice, what are those and what is their diagram, what we call them. Next, see the first one, simple cubic lattice or primitive cubic lattice. It is very simple. That is why that's why it is given as simple. Okay, how it is simple? See, there is one lattice point at each of 8 corners of a unit cell. So I told you unit cell is not always a square. If it is a square, means it is a 2D, it is a 2 in 2 dimension. Square into 3D, it becomes a cube. Okay, square in 2D shape is a square, and a square it is in 3D shape, it is simply cube. That means it is a 3 dimension of unit cell. Okay, so I have shown 2 dimensional unit cell, so it is a 3 dimensional unit cell. Okay, so there is one lattice point at each of 8 corners. See how many corners are there? Totally 8 corners are there. All the corners contain one lattice points. There is no lattice point inside the unit cell. See, only at the corners we have the lattice point. Okay, at the center or at the face side, at this side, we don't have any lattice points. So that is why it is a simple thing. Simple means only at the corners present, inside cannot present. And next is a face centered cubic lattice. There is one lattice point at each of 8 corners and one lattice point at the center of each of the 6 faces of a cubic cell. See here, there is one lattice point at each of 8 corners. So same in the cubic lattice, how do we have the same thing here we have, but extra thing is there is a one lattice point at every face. So it is a face, so it is here one lattice point, and it is a back face lattice point, left face lattice point, bottom face, and it is a front face. So totally how many? 6 lattice points are there at 6 faces. Okay, and 8 lattice points are there at 8 corners. So in the simple cubic also at 8 corners 8 lattice points are there. There is an extra point at the center of each face. So extra point is where at the center of each face. See here, it is corner, 8 lattice point present. So top face 1, back face, right face, left face, bottom face, it is a front face. So how many? This is a 3 plus 3, so 6 faces contains 6 lattice point at their centers. So that is why it is called face centered cubic lattice. Okay, that is why it's named as face centered cubic lattice. It is also cube. And next, body centered cubic lattice. What is the body centered cubic lattice? There is a one lattice point at each of 8 corners and one lattice point at the center of each cell. Okay, so here already here not given, actually here one lattice point present. Okay, it is not present. So 8 corners contains 8 lattice points. Okay, 8 corners contains 8 lattice point. 1 here, 2, 3, 4, 5, 6, 7, 8. And extra thing is what? Extra one lattice point present exactly middle of the cube. Okay, exactly middle of the cube. So that is why it is called body center, means exactly at the center of the cube. Okay, so at the center of the cell, one lattice point at the center of the cell. So that is why it is called body centered cubic lattice. Okay friends, so don't forget watching this video and subscribing, and you must watch till the end of this video. Don't forget it.